Hi, hello, very good morning, friends. This is again your Virat Kumar. After a long time, after about a week, I'm again in front of you. So, in order to continue the session of projection of planes, so I think we have seen about four kind of problems in the previous session. So, as I've said you, there will be total some 11 to 12 problems. So, we have seen about four problems in previous session. So, we'll see the next problems in this session. So again, welcome you all. So very good morning. We'll continue the session. See, this is again your problem number 5. So this is regarding the projection of planes. Projection of planes. Okay. So in order to continue, this is a problem number 5. So this is a regular pentagon of 30 mm sides is resting on HP on one of its sides, while its opposite vertex, nothing but the corner, is 30 mm above HP. And draw the projections when side is HP is 30 degrees inclined to VP. So this is the question given to you. So what is saying here, there is a regular pentagon of 30 mm side which is resting on HP on one of its side. So while its opposite vertex, nothing but the corner, is 30 mm above HP. So draw the projections when the side in HP is 30 degrees inclined to VP. So the surface inclined directly given, so side inclined also directly given. So these are some steps already we have seen to be followed. So read the problem and answer for the following question. The surface inclined to which plane? It is to HP, and the assumption for initial position is parallel to HP. And so which view will show true shape? It's the top view. So which side will be vertical? Any side. Hence begin to draw top view. Draw pentagon below XY line taking one side vertical. So now we will see the diagram. This is your XY axis line. So firstly you draw a hexagon and the HP and take and mark the points A, B, C, D and D. Take the projections to the vertical plane above the XY axis line, that is your VP. The points are B dash, these are your points. So now the only change is the manner in which surface inclined is described. One side of HP and its opposite corner 30 mm above HP. So hence draw first front view as a second front view making above arrangement. Keep A dash B dash on XY and D dash 30 mm above XY. See in this way. So okay. Now again take the positions from here, both VP and HP. Mark the points and draw the diagram. So this will be your resting on one corner with 30 degrees inclined to VP. No, 30 degrees inclined to HP. It is 30 degrees above HP, one of the corner. Okay. Now it's telling to draw the positions when side in HP is 30 degrees inclined to VP. Now 30 degrees with inclination. Draw the same figure. Take the projections from both VP and HP. Mark the points. Then draw your pentagon. This will be your required pentagon of all the constraints. So is it clear? Okay, we'll see it again. Firstly, you draw your xy axis line. I'll just show you as I have said you already. Mark the points, then take the projections to just see the illustration. Now just take a minute and draw the diagram neatly and carefully in your observation notes so that you can make it for further in your sheets. Okay, we'll move on to the next problem. See, this was your problem number 5. This is actually 6 that got mistake in something, so make it as problem number 6. So this is he given you that a circle of 50 mm dia is resting on HP on end A of its diameter AC, which is 30 degrees inclined to HP, while its top view is 45 degrees inclined to VP. So draw its projections. So the constraints are, by reading the above problem and answer the following questions, that would be surface inclined to which plane? It is to your HP, and the assumption for initial position is parallel to HP. So which view will show you the true shape? Its top view. So which diameter is horizontal? AC. So hence begin to draw top view, draw rhombus below XY line, taking longer diagonal parallel to XY. So this is your XY. We have drawn a circle with the given dia, dividing into 4 equal parts and taking the projection, that you will get a diagonal which is A dash, B dash, E dash and C dash. Now we are taking 30 degrees inclined to your HP with the same markings and points. We'll draw the projections both to the VP and HP and marking the points. We'll join all the points smoothly in order to get our elliptical curve. Since it is twisted in 30 degrees, so the circle looks in the manner of ellipse. So now by twisting this circle into 45 degrees angle, twisting the twisting the ellipse to 45 degrees inclined to VP, that to be drawn in HP, by twisting the same figure into 45 degrees and marking all the points. Now by taking the provisions in both VP and HP, mark the points for all the belonging points and join all the points smoothly in order to get your required curve. So this will be your problem number 6. Just make a note of the question and answer by taking a minute. Or else let me show you again. See the illustration once again carefully. So this is your final figure. Okay, we will move on to the next problem. Problem number 7. He given you that a circle of 50 mm diameter is resting on HP on end A of its diameter AC, which is 30 degrees inclined to HP, while it makes 45 degrees inclined to VP. Draw expressions. I think both the diagrams will see the difference in it. So here the first stage and second stage, this is your third stage, so both are same, but whereas the difference in these two problems is in step 3 only. So in the problem number 8, the inclination of top view is telling you that inclined to HP, which it makes 45 degrees inclined to VP, where in the above question inclined to HP while its top view is 45 degrees inclined to VP. So here in problem number 8, inclination of top view of that AC is given. It could be drawn directly as shown in third step. So while in problem number 9, angle of AC itself, therefore its true length is given. Hence here along of true length is taken, locus of C1 is drawn, and then LTV, therefore A1 C1 is marked, and final top view was completed. Study illustration carefully. So this will be your required projection. Just read the constraints carefully and draw the figure. Note the differences in constructions of third step in both solutions. So this is first stage, second stage, and this is your third stage. Just check the difference. So this will be your problem number 6. This will be your 7. So this is your actual required projection. So okay, now move on to the next problem. So this will be your problem number 8. So it's telling you that end A of diameter AB of a circle is in HP and end B is in VP. Diameter AB 50 mm long is 30 degrees and 60 degrees inclined to HP and VP respectively. So draw the portions of circle. So end A of diameter AB of a circle is in HP and end B is in VP. So diameter AB 50 mm long is 30 degrees and 60 degrees inclined to HP and VP respectively. Draw the portions of the circle. So before the constraints, there is problem. Answer the questions carefully. Surface inclined to which plane? It is to HP. The assumption for initial position is parallel to HP. So which view will show true shape? It's your top view. And which diameter is horizontal? AB. So hence begin with top view. Draw circle below XY line, taking dia and AB parallel to XY. So this is your XY axis line. Draw a circle in the below with the required diameter given, which is 50 mm long diagonal, which is your AB. Check the projections and take a 30 degrees inclined to HP is drawn in VP and 60 degrees inclined to VP is drawn in your HP. So first 30 degrees, draw the circle which looks like an ellipse and the same part to be so here is telling you that the problem is similar to the previous problem of number 7. But in the third step there is one more change, like ninth problem. True length inclination of dia AB is definitely expected, but if you carefully note that the sum of its inclination with HP and VP is 90 degrees, which means line AB lies in a profile plane. So hence its both top view and front view must arrive on one single projector. So do the construction according and note the cases carefully. See, this is your 60 degrees inclined to VP, which is done on HP, which is your true length. So this is your thing. So solve separately on drawing sheet, giving names to various points as usual, as the case is important. So this is your problem number 8. Note the question and constraints carefully and make the diagram firstly in your observations, then to your sheets. Okay, we'll move on to the next problem. Is it clear to you all? Okay, so this will be your problem number 9. So this will be your problem number 9. So he given you that a hexagonal lamina has its one side in HP and its opposite parallel side is 25 mm above HP and in VP. So draw its projections. Take side of hexagon 30 mm long. So it's telling you that the hexagonal lamina has its one side in HP and its opposite parallel side is 25 mm above HP and in VP as well. So draw its projections. Take side of hexagon 30 mm long. So these are the constraints. So surface inclined to which plane to HP. Assumptions for initial position parallel to HP. So which view will show you the true shape is top view. So which diameter horizontal. So this is bogus. This is for your previous one. It's telling you the diameter, so it's not. So in the same way, you need to mark an XY and draw a hexagon in the HP. Take the positions before that, mark the points A, B, C, D, and E and F. That will be your A dash, B dash, C dash, F dash, and D dash, E dash. Now he's telling you only change in the manner in which surface inclination is described. One side of HP and its opposite side 25 mm above HP. So hence redraw first front view as a second front view making above arrangement. So keep A dash B dash on XY and D dash E dash 25 mm above XY. See in this case, so A dash remains on the surface of XY and D dash E dash will be above XY of about 25 mm and mark the respective points as in the first case. So now take the projections from both VP and HP and mark the points and draw your required HP. Required projection. This is your second stage. And again he's telling you that as third step, so redraw the second top view keeping side DE on XY line because it is in VP as said in problem. So now VP, so this diagram on VP. Now take the projections for both VP and HP, draw the figure. So this is your third stage. So I'll show you again. So this he said that its opposite parallel side is 25 mm above HP and in VP. So in VP will be indicated in this way. He didn't said that any inclination to VP in VP, so we have drawn on the XY axis line. Take a minute and make the diagram carefully. Okay, we'll move on to the next problem. Now here there are some freely suspended cases, which is your problem number 10. Okay. So in problem number 10, an isosceles triangle of 40 mm long, base side 60 mm long, altitude is freely suspended from one corner of base side and its plane is 45 degrees inclined to VP. Draw its projections. So there are some important points to be noted in freely suspended cases. So in this case, the plane of the figure always remains perpendicular, and it may remain parallel or inclined to VP. Hence top view in this case will be always a line view, and assuming surface parallel to VP, draw true shape in suspended position. Here keeping line joining point of contact and centroid of figure vertical. In fact, always begin with FV, nothing but the front view as a true shape, but in a suspended position as shown in first front view. See, first given triangle with given dimensions, locate its centroid position and join it with the points of suspension. So this is your required triangle. This is your required height. With G, the point is of h by 3. So now by x axis line, see that a dash G dash as the perpendicular one, and suspend your figure. Take the projections that looks in a straight line way, so that will be to your B, A, G and C. Now taking this line of 45 degrees incline, draw the projections from all the constraints, nothing but the points. So this is your required diagram. So there is a AG point in it. So take a minute and solve the problem. I'll just show you again so that you can solve the next problem of semicircle in the same way. See carefully the illustration. I have just animated with all the points clearly so that you will be analyzed very easily. So this is your required problem. So there is a AG also here. AG also drawn. You draw a straight line from A to G on the projection line. So from A point to G. Okay, so similarly solve next problem of semicircle. So this will be your problem number 11. Problem number 11. Say a semicircle of 100 mm diameter is suspended from a point on its straight edge 30 mm from the midpoint of that edge, so that the surface makes an angle of 45 degrees with VP. So draw its projections. So this is your problem number 11. Now see the same points of previous case. So in this case the plane of the figure always remains perpendicular. It may remain parallel or inclined to VP, hence TV is in this case will be always a line view. So assuming surface parallel to VP, draw true shape is suspended position. So always begin with front view as a true shape but in a suspended position, so as shown in first front view. So first draw a given semicircle with given diameter, locate its centroid position and join it with point of suspension. Okay, center of gravity, centroid position. Now draw the xy axis line. P dash C G, which is suspended. There's your different parts in it, dividing into 4 equal parts and naming them A, B, C, D, E, nothing but A dash, B dash, C dash, E dash. Now by taking all the projections from all the points, so you will be getting B, C to C and A to A. That is your PG, that is your D and D. Now 45 degrees inclined of this line with all the points. Draw the projections and take the projections from both VP as well as the HP. Mark the points. A, B, that's your C, C to C, that's your D to D, and G to E. join all the points smoothly in order to get your required true inclination. So is it clear? Take a minute. So okay, we'll see it again. So for today's session we'll end up to this problem. Is it clear? So this is your required diagram. So today we have seen from problem number 5 to 11, so of about 7 problems. So it's more than enough for today. So this is your required diagram. Firstly you need to make this value and this to be suspended and draw the same figure, and then take your view which looks in a straight line and take the 45 degrees angle of the straight line, and by taking the projections from HP and as well as from your VP, so mark all the points and join all the points carefully in order to obtain your required diagram. So this is your diagram. So okay friends, we have seen this and this this problem. So we have seen from here. So this problem, so firstly this and then after this, then problem number 9, this is your 9th one, this is your 8th one, this is the 7th we have seen, 7 and 6 on the same slide, and this is your 5th problem. So okay, so that's it for today. So we'll end this session and again we'll meet tomorrow with the new topic of this one, where to determine the true shape of plane figure when its projections are given by using auxiliary plane method. So we'll see this and the tomorrow's session. So thank you one and all, have a nice day.